All right, we are about to dive into one of the most fundamental and honestly, one of the most fascinating challenges in the entire blockchain world. It's a problem that sits right at the critical intersection of our digital and physical lives. And solving it, well, it changes everything.
So we've got this amazing tech called smart contracts, right? They're basically self-executing agreements written in code, and they're already automating transactions and controlling billions of dollars without needing any human in the middle. The big promise here? A future built on trustless, super efficient automation.
But for all of that power and security, there's this fundamental weakness hiding in plain sight. And it's a flaw so huge that if we didn't address it, it would keep this entire revolution trapped in a digital box, totally cut off from the real world.
And here's the weakness. By its very design, a blockchain is completely blind. It has no built-in way to see what's happening outside of its own network. It can't check the weather, it can't look up a stock price, it can't even tell you the time of day. It's its own closed-off, self-contained universe.
So the obvious question is, why? Why would you build such a powerful system and then intentionally cut it off from everything else? Well, it turns out this blindness isn't a bug at all. It's actually a critical security feature. Let's break down exactly why that is.
The core idea here is something called determinism. A blockchain is what's known as a deterministic system. All that really means is that for any given input, it will always produce the exact same output, every single time on every single computer that's running the network. No exceptions.
You know, a great way to think about it is like a computer that has no internet connection. You can still run programs on it, sure, but you can only use the data that's already saved on the machine. You can't just Google a stock price or check a flight status because all that information is external and it's always changing. That's pretty much how a blockchain works.
And this determinism, this is the absolute foundation of consensus. For thousands of computers all over the world to agree on a single source of truth, they have to get the exact same result when they process a transaction. Just imagine if one computer pulled a stock price of $100 and another pulled 101. Their ledgers would instantly diverge and the whole system would just shatter.
So, okay, we get it. This isolation is essential for security, but it creates this massive paradox, doesn't it? What happens when we want to build useful applications that actually need to interact with the real world? What are the consequences of being trapped in this digital box?
Well, the limitations are huge. I mean, think about it. How can an insurance smart contract automatically pay out for a delayed flight if it has no way of knowing the flight was delayed? How can a lending platform manage a loan if it can't see the real-time price of the collateral? It can't. It just plain can't. Without access to external data, most of the revolutionary apps we talk about are basically dead on arrival.
And this is where our hero enters the story. To solve this big problem of isolation, we need a special kind of bridge, a secure gateway to connect the on-chain world with all the data from the off-chain world. We need what's called a blockchain oracle.
To put it simply, a blockchain oracle is just a service that finds and verifies real-world information, and then feeds it onto the blockchain in a secure, reliable way. Think of them as essential translators, digital messengers, that connect these two totally separate worlds.
Okay, so let's walk through how this actually works. A smart contract on the blockchain will broadcast a request, basically yelling out, "Hey, I need the current price of Ethereum." An Oracle node, which is always listening for these requests, picks it up. It then goes out to a reliable external source, like a major exchange's API, to get that price. It formats the data and then it sends it back to the blockchain in a brand new transaction. And just like that, the smart contract has the real-world data it was looking for.
And it's important to know that there isn't just one type of oracle. They can be software-based, pulling data from websites and APIs, or they can even be hardware-based, getting readings from a physical sensor like a thermometer. They can be inbound, which means they bring data onto the blockchain, or outbound, allowing a smart contract to trigger a real-world action, like telling a smart lock to open. The design is really tailored to the specific job it needs to do.
But here's the crucial twist. In building this awesome bridge to the outside world, we've accidentally introduced a new centralized point of failure right into our decentralized system. This is famously known as the Oracle problem, and understanding it is absolutely critical.
Because it forces us to ask a really tough question. We built this decentralized, trustless blockchain, but what happens if the single oracle that's feeding it data gets hacked, goes offline, or simply fed bad information?
It all comes down to that timeless computing principle. Garbage in, garbage out. If a smart contract gets bad data from an oracle, it's still going to execute perfectly according to its code. The problem is, the outcome will be based on that faulty data.
And because blockchain transactions are immutable, irreversible, that incorrect outcome is locked in forever.
And listen, this is not just a theoretical risk. In 2022 alone, over $400 million were drained from DeFi protocols through attacks that specifically targeted and manipulated their oracles. The stakes here are incredibly high.
So how do you fix the oracle problem? How do you build the data bridge that's just as secure and reliable as the blockchain it's serving? Well, the answer, as it so often is in this space, is decentralization.
Instead of trusting a single centralized oracle, which is that single point of failure we're worried about, the solution is to use a decentralized oracle network, or a DAWN. In this model, you're not trusting one single company or server, you're trusting a whole network of independent oracle nodes that all have to agree on the data before it ever gets submitted to the blockchain.
This multi-layered approach is how you actually build trust using code. First, the network pulls data from many different sources, so one bad source can't poison the well. Then, multiple independent oracle nodes all have to come to a consensus on what the correct data point is. And finally, they use cryptographic proofs to create a verifiable, tamper-proof link between the data source and the smart contract. Each layer just adds more and more security, creating an incredibly robust and trustworthy system.
So let's zoom out and just think about the bigger picture for a second. Why is solving this oracle problem so incredibly important for the entire future of blockchain technology?
Because ultimately, oracles are the key that unlocks the true potential of smart contracts. They're what transform blockchains from just being secure, isolated databases into dynamic, interactive platforms that can actually respond to and shape events in the world around us.
When you really think about it, oracles are so much more than just data feeds. They're the essential infrastructure that bridges that huge gap between digital code and physical reality. They're what makes smart contracts truly, smart. By solving the oracle problem, we're finally giving blockchains eyes and ears to perceive the world. And so, the real question we're left with is this. Now that this powerful technology can finally see, what new possibilities, what new systems, and what incredible new worlds will we build?